Okay, so we're going to go and we're going to be working on isolating specific variables. Okay, so they've given us a formula. This formula simply states A plus B equals D. Okay, and in the question they want us to isolate for the variable A. So we're going to kind of highlight that. We're trying to isolate for A in this. Okay, so what that means is we want A to be by itself on one side of the equal sign. Okay, so our equal sign, think of it like the middle of the equation. It's where our balancing point is. And since it's already on the left side, and this is the right side, okay, we want to keep A by itself on the left, let's say. It'll be easiest that way because it's already there. So that means we need to move B to the right side of the equation. Okay, now because B is positive over here, when I move it to the right side of the equation, what will it become over there?
Negative.
That's right. So we'll be left with A on the left side is equal to
D minus B.
That's it. Very simple. That's an easy one to start. Good. The second question they've given us is a circumference. Okay, circumference is equal to 2 pi r, and they want us to isolate for r. Okay, this one's a little trickier. So same idea. C equals 2 pi r. Our equal sign is the middle of our equation. This is our left side and our right side. R is already on the right side, so we kind of want to keep it there. Now, this operation means 2 times pi times r. So we can move kind of both of them at once if we like. We need to move this 2 pi to the other side. And since it's 2 pi times r, if we need to move it to the left side of the equation, what operation would we use?
Division.
Yeah, I'm going to put we use negative here. Yeah, we're going to be using a division. So it's going to read C is equal to, and what will C be below?
2 pi.
That's right, 2 pi. So C divided by 2 pi is equal to R. Right? So we moved 2 pi over and we divided by it. Okay, that's pretty straightforward. Let's actually move. We have another page here. Oops. Here you go. Next question. A equals I squared, and they want us to isolate for I. Now, this is a little trickier. Okay. Again, A is on the left side, I is on the right. We want to keep the I by itself, but we have a squared power of 2 symbol here. The opposite of a power of 2 or a power is called a root.
Yeah.
Okay. So, in order to move this to the other side, this 2, we need to use a square root on the other side. So what that's going to leave us is with the square root of A is equal to I. Okay, and we've isolated I there. Does that one make sense? Yeah. Okay. And finally, last one we want to do, this is called the equation of a line, y equals mx plus b. They want us to isolate for x. Now, same idea, we have y is equal to mx plus b. The x is on the right side of the equation, right?
Yep.
So let's kind of keep the x on the right and move everything else. Now, when we move everything else, the first thing we want to move is usually the last thing we would do in bed math. Yeah. So we're adding and subtraction. So we want to move the b first. And when we move the b over, what operation will we use?
Subtraction.
That's right. So step 1 will be y subtract b is equal to mx. Is the x by itself?
No.
No. We still have to do what? Move?
Yeah, move the m over.
Okay. Now this is m. What operations between this?
M times x.
That's right. So how do we move the m to the other side?
You would divide it, so y minus b divided by m is equal to x.
Exactly. Y minus b divided by m is equal to x. Okay? And that's it. Oh, let me just kind of get rid of this page here. There you go. And that's everything we've done. Okay? So that's how you isolate for a specific variable.